How am I to make iced lemon tea without ice cube?
You have a problem there, Professor? Can I help you?
Dot, do you have ice in here? I need some to make myself a glass of iced lemon tea.
Ice? I don't have ice. I'm a robot. I don't need to drink.
Of course you don't need to. But have you used ice in your experiments?
No, sirree. Never touched them before. My hands might get rusty if I touch them.
Okay, I think I can drink the lemon tea. It's not too hot now. If you need me, I'll be in the lab.
Okay, sir. Enjoy your drink. Huh? Where is it? Hey, maybe that tiny robot has taken it. He's been carrying out many experiments lately. Kuchen! Kuchen! Where are you, Kuchen? There you are. Why didn't you answer me when I called? Aha! The mystery of the missing ice cube is solved. So, you are the one who has taken it. Prepare for your punishment, tiny robot. Meow! Can you please keep quiet? I'm keeping my eyes on the ice cube. I want to see the melting process. What? You have never seen the ice melting before? Ooh, that's odd. Hey, do you know that the room temperature causes the ice to melt? Of course I know. Meow. Do you know that the molecule structure in matter changes from one form to another? I know that too, Dot. That's what we shall explore today. Matter. Meow. Hi there, boys and girls. Welcome to the wonderful world of science. Today, we shall learn about matter. Meow. Yes, that's right. But first, what is matter? I know. Matter is anything that has mass and occupies space. Living and non-living things are matter. Air, water, rock, wood, soil, and of course, robots are examples of non-living matter. Plants, insects, birds, fish, and human beings are examples of living matter. Meow. Heat, light, and sound are not matter. You see, they do not have mass and they do not occupy space. So, why do we say that air is matter? I know. Meow. Let me answer it. Hey! Yo, I shall answer the question by showing you an experiment. I need some string, a drinking straw, cellophane tape, and 2 colored balloons. I have set up the experiment like this. We shall now stick some cellophane tape on both balloons. Now, the balloons are equally balanced. I shall now prick the red balloon with a pin. Now, let's see what happens. You see, The red balloon has lost some air and becomes lighter than the yellow balloon. The yellow balloon is now heavier than the red balloon. This experiment shows that air is matter. It has mass and it occupies space. Now, my question is, what is matter made up of? I know too. Let me show you. Meow. Matter is made up of very small and discrete particles which we call atoms or molecules. We cannot see them by the naked eye. Hey, matter exists in 3 states. They are solids, liquids, and gases. Examples of solids are ice, beakers, and metal. Examples of liquids are water, oil, and mercury, whereas steam, oxygen, and hydrogen are examples of gases. Meow. Yo, the main difference in the 3 states of matter is solids have a definite shape. Liquids take the shape of their containers and gases take the shape of the whole container. Solids and liquids have a fixed volume. Gases do not have fixed volume. They take the volume of their containers. Solids do not flow. Liquids flow easily. Gases flow easily in all directions. Yay! Meow! Look here. The ice cube has melted. I miss the changing process. Hey, don't be sad. Let's try again. You see, the room temperature makes the particles in the solid ice vibrate so fast that it causes the ice to melt. Since we are talking about particles in matter, let me show you the arrangement of particles in solids, liquids, and gases. This is the arrangement of particles in solids. The particles are arranged closely and are packed in a fixed pattern. There's not much space between the particles. This arrangement tells us that solids have a fixed volume, a fixed shape, and cannot be compressed. Meow. Now, this is the arrangement of particles in liquids. The particles are arranged closely and are not in a regular pattern. There's much more space between the particles. This arrangement tells us that liquids have a definite volume, but no definite shape. They are difficult to compress because the particles are closely packed together. Meow. This is the arrangement of particles in gases. The particles are far apart and are not in a fixed pattern. There's much more space between the particles. The arrangement tells us that gases have no definite volume and no definite shape. They can be easily compressed because the particles are far apart. Meow. You have seen the arrangement of particles. Now, I would like to show you the movement of particles in matter. Yo, you see, particles in matter are always moving, but the movement of the particles is different. Solids are made up of particles that are held closely together by very strong forces. They can only vibrate from side to side and spin around their fixed positions. They cannot move freely. Liquids are made up of particles that are far apart. They vibrate, but they are not in fixed positions. They move randomly around one another. Collisions between the particles take place frequently. Gases are made up of particles that are further and widely apart. They move randomly in all directions at high speed. Collisions between gas particles take place more frequently than collisions between particles in liquids. They spread out as far as they can and fill up any container completely and quickly. This random movement of particles in matter is known as the Brownian movement. The Brownian movement takes place in liquids and gases. Particles in liquids and gases move randomly. What about solids? Well, the Brownian movement does not take place in solids. Particles in solids are closely packed and cannot move freely. That is why solids cannot flow. Yeah. If we observe the Brownian movement in a smoke cell under a microscope, we can see the smoke particles that look like dots moving randomly. We can also see how they collide with the air particles which move randomly. I'm now holding two cubes. The volume of each cube is 1 centimeter cube. This is a wooden cube and this is an iron cube. Although both cubes have the same volume, they do not have the same mass. You see, the iron cube has a higher density than this wooden cube. Phew! Meow! You see? For a unit volume, the density of a substance is defined as the quantity of matter in that substance. We can easily find the density of a substance if we know the mass and the volume of the substance. Just divide the mass by the volume of the substance and we'll get the density. The SI unit for density is the kilogram per cubic meter. Another unit that is often used is gram per cubic centimeter. The density of an object determines whether the object floats or sinks in liquid. An object will sink in liquid if the density of the object is greater than the density of liquid. This nail, for example, it sinks in water because the nail's density is higher than water. Meow! If an object is less dense than liquid, it will float. For example, ice. The density of ice is less than the density of water. So, when we put ice in water, it floats. Look at this example. It shows the concept of floating. Compare the densities of these solids and liquids. But do you know that we can make an object that sinks into an object that floats? Oh, yes, we can. For example, when we put this lump of plasticine into this basin of water, it sinks. Meow. But if we shape the plasticine into that of a boat, yeah, like this, yeah. I'm an artist. Woo. Now, let's put the boat in a basin of water. You see, it floats. When I shaped this plasticine into a boat, its volume increased. It became less dense, and that's why it floats in the water. This means that the density of an object can change when the object is in a different form, just like the plasticine. When it was a lump, it sank in the water, but when it was shaped into a boat, its volume increased and its density decreased. The boat that is made from the same plasticine can now float in water. Meow. We have learned that matter exists in 3 different states: solids, liquids, and gases. The different states of matter help us in our daily lives. This is an aerosol can. What's inside the can? Let's press the outlet valve to find out. Meow. Containers containing gas, such as aerosol cans and cooking gas cylinders, keep gases under high pressure. Do you know that gas can be stored in a container when the gas is in liquid form? Oh yes, this liquefied gas will become gas again when pressure is released. Neat, isn't it? Meow. Oxygen is also kept in liquid form in cylinders. Oxygen cylinders are used in hospitals to provide oxygen for sick people who need help to breathe properly. Meow. Deep sea divers use aqualungs to enable them to stay underwater for a long time. An aqualung contains liquefied oxygen. The knowledge on density is important in our daily lives. Let's see how the concept of density is used to our benefit. Meow. It is very difficult to transport logs from the jungle to a factory by land. This problem is solved by transporting them using the river. Logs can float in water because wood is less dense than water. Meow. People who are learning to swim usually have difficulty to stay afloat, so they use floats to help them stay afloat. These floats contain air, which is less dense than water. Meow. People who live in remote areas use the river as a form of transportation. They usually use rafts made from bamboo to transport goods. The raft is able to stay afloat because it is less dense than water. Meow. Fishermen use floats made of plastic to keep their fishing nets afloat. A hot air balloon has a burner to heat the air in the balloon. The hot air is less dense than the cool air around it. This enables the hot air balloon to float in the air. Now, let's recall what we have learned from today's lesson. Meow. We have learned that matter is anything that has mass and occupies space. Living and non-living things are matter. We also know that the air around us is matter. Matter is made up of small and discrete particles which we call atoms or molecules. We know that matter exists in 3 states: solids, liquids, and gases. We also know the arrangement of particles in the 3 states of matter and their differences. We have also shown you the movement of particles in solids, liquids, and gases. Meow. We have learned the concept of density in matter. Meow. The knowledge of different states of matter makes inventors invent creative things that are useful to our lives. Meow. We have come to the end of the show. We hope you've enjoyed and learned a lot about matter from our show today. So, until next time, take care. Bye-bye. Meow.
bangun desa, kita semua pasti merasa bangga. Keranamu kami mendapat tua, keranamu kami bangsa berjaya, keranamu kami hidup selesa, lempar bodi kemakmuran negara. Keranamu kami bebas merdeka, keranamu nyawa dipertaruhkan, keranamu rela kami berjuang demi bangsa kedaulatan negara. Keranamu negara Malaysia, Malaysia. Terima kasih Malaysia.
Kota Melawati ini dahulunya dikenal Kota Selangor kerana dia terletak di atas Bukit Selangor. Pentingnya kota ini yang pertama sekali kerana di atas bukit inilah tempat persemaiannya ketiga-tiga sultan yang memerintah negeri Selangor bertempat di Kuala Selangor. Sultan yang pertama Raja Lumur. Raja Lumur ialah anak dan celak dan digelar Sultan Salehuddin Shah, iaitu Sultan Selangor yang pertama. Sultan Selangor yang kedua ialah Sultan Ibrahim. Sultan Ibrahim ialah seorang sultan yang boleh dibanggakan di Selangor kerana beliau ini mempunyai tokoh. Selain daripada tokoh kedutaan, tokoh sebagai jurutera, jurubina dan juga seorang ahli fikir. Kerana di zaman Sultan Ibrahim lah negeri Selangor ditentang atau diserang oleh Belanda pada tahun 1784 dalam bulan Ogos. Tetapi dengan kekuatan kepahlawanan Sultan Ibrahim dapat menyerang semula Belanda ini dalam tempoh 1 tahun. Pada 1785, beliau telah mengumpulkan tentera daripada Pahang, daripada Pematang, bekerjasama dengan penggawa Selangor dan sahabat benar menentang Belanda semula dan dapat menghalau Belanda balik ke Melaka dalam tempoh 1 malam sahaja.